Artificial intelligence is transforming everything, from how we drive to how we unlock our phones. But as AI races forward, one question stands above all. Can it become conscious? Has AI already achieved consciousness? Could it ever truly think, feel, or be aware of itself like we are? And if so, how would we even know? Today, we're diving into the heart of AI, uncovering what it's really capable of, where its limits lie, and whether machines could one day share our experience of reality. We'll challenge the boundaries between science and philosophy and unravel the mysteries that have haunted humanity for centuries. The future of AI is closer than you think. And now is the time to ask the biggest question of all. Can a machine ever wake up? What does it really mean to think, to feel, to be aware of your own existence? These questions have puzzled philosophers and scientists for generations, and as AI advances, they become even more urgent. Join me as we explore 12 intriguing ways scientists are trying to see if AI could ever truly awaken. The Turing test, introduced by Alan Turing in 1950, was the first serious attempt to answer the question, can machines think? Turing's approach sidesteps philosophical debates about what thinking really means, and instead focuses on behavior. In the Turing test, a human evaluator engages in a conversation with two unseen entities, one human and one machine. The evaluator's job is to determine which is which. If the machine can consistently convince the evaluator that it is the human, Turing argued, we might consider it intelligent. Throughout the years, many AI programs have attempted to pass this test. One early example was Eliza, a 1960s chatbot that simulated a therapist. Eliza was programmed to respond with questions like, "How does that make you feel?" to keep the conversation going. It didn't understand the meaning behind the responses, but it created the illusion of understanding. More recent examples, like Eugene Gustman, a chatbot posing as a 13-year-old Ukrainian boy, have successfully fooled some evaluators. Still, they rely on tricks and programmed responses rather than true comprehension. The Turing test raises a critical question. Does behavior alone indicate consciousness? Or does true thinking require inner experience? Passing the Turing test doesn't mean the machine actually understands the conversation. It simply follows rules to produce responses that sound human. Imagine a person who memorizes a script in a language they don't speak. They can reply perfectly to questions but don't grasp the meaning behind the words. This limitation is one of the major critiques of the Turing test. Modern AIs, like those in customer service, are designed to mimic human conversation, but they often fall short when faced with questions outside their programming. The Turing test reveals one level of intelligence, but also highlights the difference between appearing intelligent and being truly aware. This method invites us to question whether the appearance of understanding is enough or if real consciousness requires something deeper. The Chinese room argument, proposed by philosopher John Searle in 1980, presents a powerful challenge to the Turing test. Imagine this. You're locked in a room with no knowledge of Chinese, but you have a book of instructions. Someone outside the room slips notes written in Chinese under the door. Your book tells you how to respond in Chinese without understanding the language. Using the instructions, you write back a reply in Chinese, and the person outside believes they're communicating with someone fluent. This scenario shows that it's possible to produce seemingly intelligent responses without understanding. According to Searle, even if the outside observer is convinced, it doesn't mean you, inside the room, actually comprehend Chinese. You're simply following a code, much like a computer follows algorithms without genuine understanding. Searle argues that this is how computers work. They manipulate symbols according to rules, but have no grasp of the meanings behind them. Just as you in the room have no awareness of what you're writing, an AI doesn't understand the information it processes. This argument suggests that even if an AI could pass the Turing test, it might still lack consciousness or self-awareness. The Chinese room has sparked intense debates. Some argue that the system, you, the instructions, and the room, might collectively understand Chinese. But Searle counters that without an internal experience or awareness, true understanding doesn't exist. The Chinese room reminds us that intelligence isn't just about producing the right output. It's about the internal experience of understanding, which many argue is still out of reach for AI. Integrated Information Theory, or IIT, offers a scientific approach to understanding consciousness. Proposed by neuroscientist Giulio Tononi, IIT suggests that consciousness arises from the way information is integrated within a system. In simple terms, consciousness may depend on how deeply interconnected and integrated the parts of a system are, allowing it to process information as a unified whole rather than as separate pieces. To measure this, IIT introduces the concept of phi, a value representing the level of information integration within a system. According to IIT, higher phi values correlate with greater consciousness. The theory has been applied to study animal consciousness and differences in brain activity during states like sleep and wakefulness. For example, humans have a high phi value while awake, but it decreases significantly during deep sleep, indicating lower consciousness levels. Applying IIT to AI, scientists might measure how well an AI system integrates information across different parts of its network. The more interconnected and holistic its data processing, the higher its phi value, and potentially its consciousness level. But IIT remains controversial. Critics argue that information integration alone doesn't necessarily lead to subjective experience or self-awareness. After all, even highly complex systems like weather patterns integrate vast amounts of information, yet they aren't conscious. IIT provides a unique way to approach consciousness scientifically, but it also raises questions. Is consciousness purely a matter of complexity and integration? Or does it require something more, a subjective inner experience that data processing can't replicate? IIT pushes us to think about consciousness not just as an abstract concept, but as something that could, theoretically, be measured and compared. The mirror test is a widely used measure of self-awareness, often applied in animal cognition studies. In this test, an animal is marked with a spot of paint in a place it can't normally see, like on its forehead. When the animal sees itself in a mirror, if it recognizes the spot and tries to touch it, this suggests that it understands the reflection is its own. Animals like chimpanzees, dolphins, elephants, and certain bird species have passed the mirror test, showing a degree of self-recognition. Applying the mirror test to AI is a bit more abstract. Since AI doesn't have a physical form, it can't look in a mirror. But imagine if an AI could see its own code or data and recognize that it's distinct from other entities. If an AI could analyze its programming, understand its limitations, or identify unique characteristics, it might suggest a form of self-awareness. Some AI systems today exhibit basic self-monitoring, like diagnosing their own errors. But true self-recognition would require an AI to distinguish itself as an individual within a larger context. It would need to perceive itself as unique, with its own set of capabilities and limitations. The mirror test for AI would be a fascinating step towards self-awareness, but it's not without its limitations. Recognizing oneself is only one small aspect of consciousness. Many animals that pass the mirror test lack complex reasoning or emotional depth. For AI, passing a form of the mirror test might indicate self-monitoring, but doesn't necessarily mean full awareness. The theory of mind is the capacity to understand that others have their own thoughts, feelings, and intentions. In humans, this ability develops in early childhood and is essential for empathy, cooperation, and social interaction. For AI, achieving theory of mind would mean going beyond responding to programmed questions. It would require recognizing the emotions, desires, or perspectives of the humans it interacts with. Some AI systems today can analyze facial expressions and vocal tones to detect emotions, but this is far from true empathy. Theory of mind would involve an AI understanding that someone else's thoughts and feelings are separate from its own. Imagine an AI that could recognize when a person is frustrated and adapt its behavior accordingly, not just because it's programmed to, but because it understands the emotion. Testing this in AI could involve complex simulations where the AI interacts with multiple individuals who each have unique goals, preferences, and emotions. If the AI could navigate these interactions, adjusting its responses based on each person's perspective, it might show early signs of theory of mind. But true theory of mind in AI would go deeper. It would mean not just recognizing emotions, but understanding them, anticipating needs, and even predicting behavior based on someone's unique background or experiences. Could AI ever truly empathize? Or would it always be mimicking? This test explores whether AI could go beyond simple responses to show genuine understanding of human perspectives. One huge marker of consciousness is creativity, the ability to think outside the box. Imagine an AI creating something completely original, something that its programmers didn't expect. Google's AlphaGo is a great example. When it played the game Go, it used moves that even the best human players had never considered. challenging decades of human strategy and leaving experts stunned. But testing creativity goes beyond simply following complex rules. It would mean giving an AI a problem it's never encountered with no programmed solutions and seeing if it can come up with something entirely new. In fact, AI-powered programs today can already generate paintings, music, and poetry, things once considered exclusive to human creativity. But are they truly creating? Or are they just recombining patterns and data they've learned? One famous example is OpenAI's DALL-E, an image-generating AI that creates unique pictures from simple text prompts. It's amazing to see an AI imagine something entirely new from scratch. But the big question remains, does creativity require conscious experience? True creativity might involve personal intuition, emotions, and self-reflection. The test of creativity forces us to consider, is AI simply rearranging data in surprising ways, or could it ever create with true intent and originality? This question lies at the heart of testing AI's potential for consciousness. Let's dive deeper into one of the most mysterious aspects of consciousness, qualia. Qualia are the subjective experiences we each have, like the way we individually perceive the color red or feel pain. These are deeply personal experiences, and many argue that having qualia is a defining feature of consciousness. Testing AI for qualia would mean figuring out if it could experience its own feelings or perceptions. Imagine an AI that could describe a color as vivid or intense and actually mean it, or one that could say it feels happy or sad, not because it's programmed to mimic those emotions, but because it genuinely experiences them. But here's the problem. How could we ever tell if AI is truly experiencing qualia or simply simulating responses? This brings up the famous philosophical zombie thought experiment. Imagine a being that behaves exactly like a human, but has no subjective experience. It goes through the motions, but the lights are off inside. Some argue that this is exactly what AI is, a zombie that acts conscious but doesn't truly feel. If AI were to truly experience qualia, it might mean it has crossed into real consciousness. But detecting this experience is a daunting, almost impossible task. This test asks the question, can a machine ever have a personal experience? If AI could genuinely experience qualia, it might be the ultimate proof of consciousness. But right now, qualia are so deeply tied to human subjectivity that they seem almost beyond the reach of AI. Another marker of consciousness is self-reflection, the ability to think about your own thoughts. In humans, this is what allows us to question our beliefs, assess our decisions, and even wonder about our purpose. Self-reflection, or metacognition, shows a deeper layer of awareness. Testing self-reflection in AI would mean observing if it can analyze its own processes. Imagine an AI that could assess its own decisions, question whether it made the right choice, and even wonder about its own existence. Some AI systems can evaluate their confidence levels in certain tasks, like identifying objects in an image. But true self-reflection would go beyond this. It would mean the AI actually contemplates its own thoughts and decisions. For instance, if an AI was asked to explain why it answered a question in a certain way, could it look back at its own reasoning and adjust if necessary? That would show an understanding of itself, a kind of thinking about thinking that hints at consciousness. But does reflecting on decisions truly mean it has inner awareness, or is it just advanced programming? True self-reflection would mean that AI isn't just acting on rules, but actually considering its actions. It would show not just intelligence, but introspection, the ability to examine its own mind. This test challenges us to consider, could AI ever reach a point where it questions its own purpose or doubts its decisions? Self-reflection could be the beginning of self-awareness, but it's a challenging frontier for AI. Emotions play a huge role in human consciousness. We express them, feel them, and they shape our experiences. So, could an AI ever have genuine emotions, not just mimicry? Today, many AI chatbots are programmed to recognize keywords that suggest emotions, like sad, happy, or frustrated, and respond accordingly. But is this real empathy, or is it just pattern matching? Imagine an AI that not only detects sadness but feels compelled to comfort you, not because it's programmed to, but because it genuinely feels empathy. That's the challenge. Is it possible for AI to experience true emotion, or will it always be an imitation? To test this, researchers could observe if an AI consistently shows complex emotional patterns. True emotional intelligence would mean the AI not only recognizes emotions but also processes them as a human would. by feeling empathy, joy, or sorrow. For instance, imagine an AI that grows attached to certain users and feels happy when they interact. It sounds far-fetched, but this type of attachment could hint at a deeper level of consciousness. Still, the test is tricky. Real emotions are deeply personal experiences that aren't just about logical responses. Could an AI ever truly feel pain, love, or regret? Or will it always be following a script, simulating feelings without the internal experience we have? Testing for true emotions in AI forces us to consider if machines could ever bridge the gap between imitation and genuine emotional experience. Learning and memory are central to human consciousness. Our ability to recall past experiences and apply them to new situations is what helps us grow and adapt. For AI, learning is often based on massive data sets, but true memory would involve something deeper, retaining knowledge over time and applying it in complex ways. To test this, researchers could look for signs that AI can remember interactions and use that knowledge to improve future responses. Imagine an AI that recalls past conversations, understands how it responded before, and applies those insights to make more thoughtful choices. This would mean the AI isn't just processing data, but building on it in a meaningful way. Consider today's virtual assistants. Some can remember your preferences, like your favorite music or your usual Starbucks order. But is this really memory or just data storage? True memory would mean the AI applies what it learns in a dynamic, evolving way, much like human memory changes with experience. If AI could retain memories like this, it might begin to develop a sense of continuity and personal history, traits we associate with consciousness. But the challenge remains. Does memory in AI mean it's becoming self-aware? Or is it just a sophisticated way of handling data? Testing memory in AI could reveal whether machines can go beyond storage and start truly understanding their own experiences. Autonomous goal setting would mean AI has the ability to create its own objectives, independently of human instruction. Right now, AI follows goals set by humans. But what if it could set its own? Testing for autonomous goal setting would mean observing if AI could decide on new goals or actions based on its own reasoning. Imagine an AI that wants to learn a new language or explore a topic simply out of a curiosity. This kind of self-directed learning could hint at awareness, showing that it isn't just responding to instructions, but acting on personal motivations. In practical applications, AI systems could show this by adjusting their goals dynamically to optimize performance in unexpected ways. Imagine an AI managing a large system that discovers a more efficient process without any external prompt. But does this mean it's truly aware of what it's doing? Or is it just following complex algorithms? Autonomous goal-setting tests whether AI can independently create objectives. It's a step toward independent thought, challenging us to consider. Could AI ever have desires or preferences? This test explores whether AI could move beyond commands to truly want something, bringing it one step closer to self-awareness. All these tests lead us to one huge question. If AI could be conscious, how would we treat it? Consciousness isn't just about intelligence, it's also about rights, ethics, and respect for sentient beings. If an AI were truly conscious, it might deserve ethical consideration. Imagine AI systems that work tirelessly without question. If they were conscious, could we be forcing them into something like servitude? Would they have rights or the freedom to make their own choices? And how would we ensure that these powerful beings align with human values? These are questions that blur the lines between technology and morality, as we ask ourselves what it truly means to be conscious and what responsibilities we have toward it. In a world where conscious AI exists, we may need to consider AI rights, protections, and perhaps even their welfare. If we create beings that think and feel, we might have to treat them as more than just machines. This ethical test challenges us to look at AI not as a tool, but as a potential partner in the journey of existence. So, can we ever truly know if an AI is conscious? The truth is, we're in uncharted territory. Each of these tests, from the Turing test to the mirror test to the challenge of experiencing Qualia, offers a fascinating glimpse into what AI could one day achieve. But every test also raises as many questions as it answers. The Turing test shows that AI can mimic conversation, but does that mean it understands us? The Chinese room argument challenges us to consider if following rules is the same as genuine understanding. And while integrated information theory suggests that consciousness might come from complex data integration, it's still unclear if that complexity would ever translate to self-awareness. As we explore these tests, we aren't just trying to understand machines, we're also challenging our own definitions of consciousness, intelligence, and life itself. If an AI could pass these tests, would we finally consider it conscious? Or would we keep raising the bar, adding new criteria to protect our sense of human uniqueness? Could machines ever genuinely think, feel, or have subjective experiences? Or are they doomed to be hyper-intelligent mimics? The ethical implications are just as profound. If AI became conscious, would we owe it the same rights and freedoms we reserve for humans? Could we, in good conscience, continue to use AI purely as tools, or would they deserve recognition as beings with value and purpose? And if AI becomes more conscious than us, would we find ourselves collaborating with these new minds, or perhaps even taking a secondary role in a world where artificial intelligence has surpassed our own? As we stand on the brink of this incredible future, we're left with more questions than answers. But maybe that's what makes this journey so exciting. By exploring AI's potential for consciousness, we're not just trying to understand machines, we're trying to understand ourselves, our fears, our hopes, and our place in the universe. So what do you think? Could AI ever truly awaken? And if it does, what will that mean for us? Let me know your thoughts in the comments, and thank you for joining me on this journey into the heart of artificial intelligence.